Welcome. Today we're going to be going through the June 2020 paper 1 for Pure Math Unit 2. With that being said, let us now go ahead and begin. Question 1, it says, which of the following is a sketch of the locus of the points represented by the complex number z minus 5i equal 3? Now, anytime you have the modulus of z minus 5i equal to 3, all you need to do is remember you have to put it in this form, z minus in bracket. Notice there's no real number here, so it's really 0 plus 5i close bracket, the modulus of that equal to 3. So that means that the center of the circle, the center is 0, 5. The center is 0, 5. All right, the real number is 0, the imaginary number is 5, and it have a radius of 3. So go look which option is that. 0, 5, option A out. 0, 5, x is 0, y is 5, that look like option B. So number 1 is option B. Nice. Number 2 says the root of the equation x squared plus 1 equals 0 r. So if you're solving this equation, you get x squared is equal to negative 1. When you square root both sides, you get x is equal to the square root of minus 1. And you get plus or minus when you square root, but the square root of minus 1 is I. So you get x is equal to plus or minus I. Plus or minus I, that's option D. So number 2 is option B. Nice. Number 3, it says integrate sec squared over tan. Now when you differentiate tan, you get sec squared. All right, so what we end up have is, let's say you were doing u substitution. You let u equal tan x, then you have du is equal to sec squared x dx. Then what this integral would become, let's call it I. That integral I would become I is equal to the integral of 1 over 2 times u du. You can factor out the half, and you get a half, the integral of 1 over u, and the integral of 1 over u is ln u plus some constant c. But then what was u? U was tan x. So it's a half ln tan x. So that's option A. Nice. Maybe not so far yet. Nice and easy, having lots of fun. Nice. So that's number 3. Number 4 says the complex number z equal to 1 over 1 minus I can be represented on the Argand diagram as, so this complex number z is equal to 1 over 1 minus I. You see this part right here? What we can do is put it back in its standard form by rationalizing. So multiply 1 over 1 minus I multiplied by the conjugate, which is 1 plus I over 1 plus I. So in the numerator going to become 1 times 1 plus I is 1 plus I over 1 minus I times 1 plus I. When you multiply 1 minus I times 1 plus I, that's the difference of 2 squared, which is 1 minus I squared. And 1 minus I squared is minus 1, so 1 minus I squared is 2. So this is 1 plus I over 2. So that means the real part is a half and the imaginary part is a half. So that's the complex number in option A. Easy. So the real part is a half and the imaginary part is a half. Question 5. Find the value of the cos of pi by 4 plus I sine pi by 4 raised to the 4th power. We're going to use the Moivre's theorem to do this. So remember, the Moivre's theorem tells us that we can bring down the power to get the cos of 4 times pi by 4 plus I sine 4 times pi by 4. Now this 4 cancel this 4, but then the cos of pi is negative 1. So this becomes minus 1 plus This 4 cancels this 4, and the sign of pi is 0. So this is I times 0. So this becomes just -1, which is option B. Nice. Yeah, man. Question 6. The gradient of the tangent to the curve x cubed minus 2x plus 2xy plus y squared equals 5 at 2, 1. So we need to differentiate this curve. When you differentiate x cubed, you get 3x squared. Minus, we need to differentiate 2xy. Now we're going to use product rule. We keep the first 2x, then we multiply it by the derivative of the second. When you differentiate y, you get dy by dx, or we're at y prime, plus keep the second y times the derivative of the first. When you differentiate 2x, you get 2, plus when you differentiate y squared, you get 2y times dy by dx. And that's equal to 0. So now we need to make dy by dx the subject. Now I'm just going to take us to the white screen because we're going to have a little bit more space when we go to the white screen. So we had 3x squared minus in bracket, I think it was 2xy prime plus 2y times y prime equal to 0. And so this is the equation we have. Simplifying, it's going to be 3x squared minus 2xy prime minus 2y plus 2y times y prime equal to 0. So from these two, we can factor out the equations with y prime because we're trying to make y prime the subject, which is dy by dx. Remember, y prime is the same as dy by dx. All right, so that's what we're going to use to find gradient. So from that now, what we're getting is bring over the 3x squared over here. So we're going to get minus 2x y prime plus 2y times y prime is equal to 2y minus 3x squared. So we can factor out y prime now. Factor out y prime, and we're left back with 2y minus 2x equal to 2y minus 3x squared. And so we can divide both sides by 2y minus 2x to get dy by dx is 2y minus 3x squared over 2y minus 2x. Now what are we needed to do? We need to plug in the point, and this is when x is 2 and y is 1. So just to go back, see it here, we need to find the gradient at 2, 1. So to find the gradient at 2, 1, we plug in when x is 2 and y is 1. So when x is 2, the gradient dy by dx is going to be 2 times 1 minus 3 times 2 squared over 2 times 1 minus 2 times 2. In the numerator, going to be 2 times 1 is 2 minus 3 times 2 squared is 4. 4 times 3 is 12, so this is 2 minus 12 over 2 minus 4. 2 minus 4 is negative 2. So that's going to be 2 minus 12 is negative 10. Negative 10 over negative 2 is 5. So the gradient we're getting is 5. Here it is, option C. All of that work for 5, you know, so much nice. Beautiful. Nice. Now this says to differentiate cos inverse of x over 2. So we're going to do it in the whiteboard here. So we want to find the derivative of cosine inverse of x over 2. So to differentiate cos inverse of x over 2, when you differentiate cos inverse, you get minus 1 over the square root of 1 minus whatever is in the bracket square. So it's 1 minus x over 2 squared. But then you multiply it by the derivative of what's in the bracket. The derivative of x over 2 is a half. So this is going to work out to be negative 1 over 2 times the square root of 1 minus x squared over 4. Because we squared it. Now, if you wanted to simplify it some more, you see this number 2 right here. So 2 can be written as, look at this, you know, beautiful. 2 can be written as the square root of 4. So this is the square root of 4 times 1 minus x squared over 4. And so then now the square root of a times the square root of b is the square root of a times b. This is then minus 1 over the square root of 4 times 1 is 4 minus x squared. So it's minus 1 over the square root of 4 minus x squared. So we're going to look at our options. Minus 1 over the square root of 4 minus x squared. That is clearly option A. Nice. Question 8. If dy by dx is 2xy, then d2y by dx squared is, so dy by dx is dxy. So to find d2y by dx squared, I'm just going to call it y double prime. We need to differentiate twice. Keep the first, which is 2x times the derivative of the second, y prime, plus keep the second, which is y times the derivative of the first. When we differentiate 2x, we get 2. So this is the second derivative. Now at the point 1, 2, remember y prime is 2xy. So this is really 2x times 2xy plus 2y. That's what that is pretty much telling us. That's d2y by dx squared. And so what we need to find now is we need to find the gradient at 1, 2. So put x as 1 and y as 2. 2 times 1 times 2 times 1 times 2 plus 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So that's 8 plus 2 times 2 is 4. 8 plus 4 is 12. So that's option C. Nice. So that's question number 8, which is option C. Question 9. It says the number of bacteria present in a culture is modeled by the equation y is equal to y naught e to the kt, where k is greater than 0. Y is the population after t years, and y naught is the initial growth. The rate of growth is the first derivative. So we need to differentiate it to find dy by dt. And dy by dt is when you differentiate e to the k times t, that's when you differentiate e to the k times t, you get k times y naught e to the k times t. So which one is this? K times y naught e to the k times t. But then we need to plug in when t is 5. So when t is 5, I get k times y naught e to the k times t is 5. So that's 5k. So which one is that? Option B. Nice. Question 10. Integrate 1 over 1 plus 9x squared. So we need to integrate 1 over 1 plus 9x squared. Let's do that right here on the white screen, because I just want us to have a little bit more space. So we're integrating 1 over 1 plus 9x squared dx. All right. So if this is what we're integrating, this is what we do know how to integrate. We do know the rule that tells us that the integral, this is the rule in the integral of a over a squared plus x squared dx, right? We know that this is equal to tan inverse of x over a. That's what we do know. Now, however, this right here so is 9x squared. All right, so look how we're going to rewrite this now. We're going to rewrite this as the integral of 1 over 1 plus 3x squared dx. So now what do we need? What we need is that this is now our x squared. All right, so this is what we're integrating. You see the 9x squared could have been broken down as 3x all squared. All right, 9x could have been broken down as 3x all squared. If you were to do some sort of u substitution, maybe write u equal 3x, then your du would be 3dx. All right, so what we do is multiply this, put a 3 here, and put a 1 over 3 right here. So now you can look at it as 1 over 3 times the integral of, now since this is 3 dx now, this part make it become 1. You see that 3 dx here now becomes du. So this is 1 du over the 1 plus 3x squared. 3x is a u, so this become 1 plus u squared. So then this gives us 1 over 3. To integrate 1 over 1 plus u squared, that's just tan inverse of u. But then what was u? U was 3x. So it's 1 over 3 tan inverse of 3x. Plus some constant, of course, k. That's it. And that gives us option 1 over 3 tan inverse of 3x. That's option B. Question 11. It wants us to integrate from 0 to... Now, you see a question like this now, I'm just going to take out my calculator. All right, you see the question here, we don't need to do no whole heap of transposing. So we're going to take out our calculator and we're going to put it in radians first and foremost. And we're computing the integral of sine square. Now you can't write sine square in the calculator. So this is how you're going to write sine square. You're going to write the sine of in bracket. Look at this, x over 4. So press alpha x over 4. Close up that bracket. Now we need this to be squaring because it's the sine of x over 4 being squared. Now we're going from 0 to pi. So put that in the calculator. We get 0.5707. Now, I know this is 0.57. Now look at this. I'm going to take out another calculator. Remember that pi by 2 is 1.57. So because I couldn't bother work it out of being lazy with so much transposing, I'm just showing you. Look at this. This is pi by 2. Pi over 2. This is pi by 2, 1.57. So if I have pi by 2 minus 1, that's 0.57. So it's pi by 2 minus 1, and pi by 2 minus 1 is option C. I couldn't bother to transpose and then integrate this. Too much work. All right, so that's option C. Number 12, given that this is a differential equation, then the solution can be expressed as, if dy by dx is equal to y squared minus 1, let's do that on the whiteboard. We're not going to solve it, we just want to prove what the solution can be equal to. They tell you dy by dx is y squared minus 1. Now you see this now? Think of y squared minus 1 as being in brackets. You can cross multiply to get dy is y squared minus 1 times dx. And then we can divide both sides now by y squared minus 1. And by dividing both sides by y squared minus 1, this cancels this. But then this part can be seen as 1 over y squared minus 1 dy equal to 1, equal to just 1 dx. Now, when you get to this stage now, you might say, what do we do? Now, what we do is we integrate both sides. But before we can integrate 1 over y squared minus 1, we have to recall that 1 over y squared minus 1, remember, this can be separated using partial fraction, because y squared minus 1 is just y plus 1 times y minus 1. It's a difference of 2 squared. So that part can simply be written as the integral of 1 over y plus 1 times y minus 1 dy equal to the integral of 1 dx. Now this part, you can go further and separate it using partial fraction, and then say it's the integral of maybe a over y plus 1 plus the integral of b over y minus 1 equal to the integral of 1 dx. That's if you want to take it a notch further. So that's going to be, looking at it, we actually have to separate it using, and we even have to break, we have to even find the values. So we don't finish yet. Notice it's in numbers in the numerator. So pretty much we're going to need to be able to find what's A and B. So you see how much work they're giving us to do? Now we need to find what is A and B. That's crazy. So let's go ahead and find what is A and B. So in this case, in any case, we can say 1 over y plus 1 times y minus 1 is equal to a over y plus 1 plus b over y minus 1. Draw the fraction, y plus 1, y minus 1. Y plus 1 into the denominator, that is giving us a times y minus 1 plus b times y plus 1, and this is equal to 1. Equating the numerators, go around here, we're getting 1 is equal to a times y minus 1 plus b times y plus 1. That's by equating the numerators. So notice there are no y over here. This is really 0y. So this is saying ay minus a plus by plus b. All right, then we can group up the y terms, ay plus by, close the bracket, plus this is now b minus a, and this is equal to 0y plus 1. And so 0 is equal to a plus b, that's equating the y parts, and 1 is equal to b minus a. Solving them simultaneously by adding, 0 plus 1 is 1, b plus b is 2b, a plus minus a gone, so b equal to a half. If b is equal to half, b minus a is equal to 1, and a plus b is equal to 0. So therefore, a must be negative a half. Yep, negative a half. So that's it. A is negative a half, b is positive a half. So that means that this, we can rewrite that the integral is, if you replace this now with the half, then this would become, I'm just going to put in the half right here, this would be 1 over, this part is negative a half, so put a minus on the outside here. And then this b is with the positive half, so put a 1 here, and put the 2 down here, put the 2 out here as well. All right, so that's all supposed to get. So go back, it's the 2 in the denominator of 1 over 2 times y minus 1 minus 1 over 2 in bracket y plus 1. That's option D. Looking back at what we have, it's option D. All right, this one is option D. So that's it. Nice. No ifs at all. Now this one right here says we need to find the derivative of y equal ln cos x over sin x. So first thing, we'll differentiate. When you differentiate, well, before we differentiate, we'll call this u. Write down ln u. To differentiate ln u, right? Let's call y. We're calling this u. So let me just clear this. We're calling this u. We're calling u the cos of x over the sine of x. Okay? So let's do it on the white screen so I have a bit more space. So y is equal to ln cos x over sine x. All right, so call this u. So let u be equal to cos x over sine x. So what we have then is y is equal to ln u, and so dy by dx is going to be equal to dy by du multiplied by du dx. Now dy by du is, when we differentiate ln u, we get 1 over u multiplied by du dx. Now what is du dx? When you differentiate cos x over sine x, now cos x over sine x is really the cot of x. All right, when you differentiate cot x, you get minus cosec square x. When you differentiate cot x, you get minus cosec square x. And then you have 1 over u right here. But what was u? U was cos x over sine x. So 1 over u is going to be sine x over cos x, which is tan x. So this is tan x times minus cos x square x. So that's it, tan x times minus cos x square x. If you want to simplify it, which we need to do, because now we're getting dy by dx is tan x times cos x square x, put back the minus. We know tan x is sine x over cos x. We know cosec is 1 over sine square x. Put back the minus sign. So now a sine from here cancel out the square here. So end up just get minus 1 over cos x times sine x. So it's minus 1 over cos x times sine x. That's it. Minus 1 over cos x sine x. Okay, that is not right there. So let's see if we can simplify it. Now, minus 1 over cos is 1 over cos is, and 1 over sine. So 1 over cos is sec. So this is sec x, and 1 over sine is cosec x. So that's minus sec x cosec x. That's option B. Nice. All right, now question 14 says the principal argument of the complex number is, first thing is you need to look at which quadrant this complex number is in. Minus 2 plus 2i. When x is minus 2, that's over here. This is minus 2, this is 2i. So the complex number, the argument is all of this. So it's an angle that is going to be bigger than 90, but less than 180. Even without working it out, we can already see that the angle is going to be, it can't be negative, it has to be the 3 pi by 4. This is going to be the angle. All right, it has to be the 3 pi by 4. All right, if you don't believe it's 3 pi by 4, you could go ahead and work it out. All right, you could go ahead and work it out and tell them that it is. Remember, to find the angle in the second quadrant, it is pi plus. So it's pi plus the tan inverse of y over x. So it's pi plus 2 over negative 2. You go ahead and work it out. Oh, my calculator is not in radians. You always put a calculator in radians. See there, 3 pi by 4. So easy stuff that, man. Come on, man. Question 15. In a chemical reaction, the amount of substance S present at time t is modeled by the differential equation, where A, B, and K are positive constants and A is greater than B. Given S equals 0 when t equals 0, then an expression for S in terms of t may be found by solving the differential equation. So when S is 0, we know t is 0. That's initially solve the differential equation. So let's just go ahead and write down that differential equation. Okay. So around here we have ds by dt is equal to, let me look back at what the equation is. ds by dt is k times as minus b times s. K times in bracket a minus s times b minus s. So we need the s then on one side. So we can divide both sides by a minus s times b minus s. All right, and so dividing both sides by a minus s times b minus s, as we can clearly see then, what we end up get is, and also multiply both sides by dt, so you get 1 over a minus s times b minus s ds is equal to cross multiply the dt, and you get k times dt. Now all we need to do is to integrate both sides. Now we're integrating both sides now. What we're going to get is just the integral of 1 over a minus s times b minus s ds is equal to the integral of k dt. That's all. Which one is giving us that? Now, as you can see, we replace the dummy variable. So to become definite integral, we change the s here to x and integrate from 0 to s. That would give us back our answer. So what I'm saying is, if you wanted to rewrite this, you could also rewrite this as the integral from 0 to s of 1 over, where the variable s is, you write x, so it's a minus x times b minus x dx equal to the integral from 0 to t of, then you change the dt to a different letter. Which letter did they change it to? It doesn't even matter. We can even use y. And they did use y. So that one was option. Which one is looking like ours? 1 over a minus s times b minus x equal to the integral from 0 to t of k dy. All right, which one is that? 1 over a minus, that look like option B. That's it. Nice. All right, question number 16 says for 2n is between 1 and minus 1. It says evaluate the sum from 0 to infinity of 2n raised to the r. So if you're to plug in 0, you get, plug in 0, you get 0. Plug in from r is 0, right? Let me see, 2n to the 0. Oh, anything to the 0 is actually 1. So that would be when you plug in that, you get 1 plus 2n raised to the first power plus 2n raised to the second power and continue. Now, as you can see, this is a geometric progression with common ratio, and the common ratio is 2n. But since they're telling us that 2n is between 1 and negative 1, they will know that it converges. Since it's converging, then the sum to infinity is going to be a, the first term 1, over 1 minus the common ratio r. And the common ratio in this case is 2n. So it's 1 over 1 minus 2n, that's option B. Okay, question 17. Question 17, find the value of the sum from 1 to infinity of 2 times a quarter to the n minus 1. So first thing we can plug in, when plugging n as 1, you get 2 times, when n is 1, 1 minus 1 is 0, a quarter to the 0, anything to the 0 is 1, so you get 2. Plus when you plug in n as 2, 2 minus 1 is 1, a quarter raised to 1. All right, so I know you're not seeing it, so you just have to follow and imagine it. All I did is put in, all I did was plug in when it is 1 first. Then when I plug in the n as 2, it's just 2 plus a quarter raised to the 2 minus 1. And then I plug in when it is 2, 2 times a quarter to the 2 minus 1. Then I plug in now when n is 3, 3 minus 1, and so forth. So what I'm getting is 2 plus, this is now 2 minus 1 is 1, a quarter to the 1 is 1, 2 times a quarter is a half. Plus this part now is 3 minus 1 is 2, a quarter square is 1 over 16, 2 times 1 over 16 is 1 over, 2 times 1 over 16, 2 over 16 is 1 over 8. So this also looks like a geometric progression. Now, just to confirm that's a geometric progression, we know all geometric progressions have a common ratio. So to test if it have a common ratio, let's divide a half by 2. A half divided by 2, that should give us a quarter. And let's divide 1 over 8 by a half. So divide 1 over 8 by a half and see if we get a quarter too. Yes, we do get a quarter. So now we know that the sum, this is going to be equal to, the sum to infinity is 2 over 1 minus the common ratio of a quarter. You put that in a calculator. So put that in a calculator because it's a geometric progression. 2 over 1 minus a quarter. We put that in our calculator and we get 8 over 3. That's it. Beautifully done. 8 over 3. Nice. So now, question 18 says, the binomial expansion of n choose 2. Always remember that n choose 2. The general rule is n choose r. Let me write it here. Is equal to n choose n minus r. So in this case, n choose 2 is the same as n choose n minus 2. So that's option B. Easy. Okay, question 19 says the third term in the expansion of the power series of 1 plus x to the minus half is, the third term is the x squared term. 1 plus x to the minus half. So first we have to remember, let me write it all the way over here. 1 plus x to the minus half. Remember, it is equal to 1 plus n times x So it's minus a half times x plus n times n minus 1. So it's n minus a half times n minus 1 minus 3 over 2 times x squared. And that's being divided by 2 factorial. So what we get then is minus 1 times minus 3 is 3. 2 times 2 is 4. 4 times 2 is 8. This part is 3 over 8. So that means that the x squared term is 3 over 8 x squared, and it is positive. So that's 3 over 8 x squared. All we did is work out this part because they said they want the x squared term. That's it. Nice. That's question 9. All right. Question 20 says, find the sum of the first n term of the series 1 minus a quarter to the n. And then they say find the value of the second term. So first thing, they told us that the sum is Sn is equal to 1 minus a quarter raised to the n. Let me confirm that that is what they said. 1 minus a quarter raised to the n. Okay, so find the second term. So first thing, the sum of the first term is 1 minus a quarter. So S1 is 3/4. So that means that the first term is 3/4. S2 is going to be 1 minus a quarter square, which is going to be 1 minus a quarter square is 1 over 16. 1 minus 1 over 16 is 15 over 16. But remember, S2 is equal to the first term, 3/4, plus the second term, T2. And that is 15 over 16. That's what we do know. That's what S2 means, the first term plus the second term. So since the first term is 3/4, that means the T2 is going to be 15 over 16 minus 3/4. LCM, 16 into 16. That's 15 minus 4 into 16 goes 3 times. 4 into 16 goes 4 times. 4 times 3 is 12. 15 minus 12 is 3, so that's 3 out of 16. That's the second term. 3 out of 16. That's option A. All right. Question 21. Find the value of this right here. I know this is a repeat. Can't remember which one it is. I know it is an plus 1 and an plus 2. Yeah, option C. I know that's a big repeat, man. This is a big repeat. I'm not very familiar with the repeat answers because there's so much papers, but I know that one is a definite repeat. Okay, it says, given that un represents the nth term of a sequence, which of the following converges? So which one, if we find the limit, it's going to give us, let me see, if we were to find the limit of this one, right? Let's find the limit of the first one. If we find the limit of the first one in option A, first thing, all right, we definitely know this one diverges, right? We just cancel out the one that diverges. This one is alternating, so we know it is either between option A and option C. So now we need to find the limit of these to see which one is going to give us a finite value, and that one converges. Now, why did I cancel out those two? Because I don't want to find the limit of all of them. I want to just eliminate those. So now we want to find the limit as n approach infinity of the first one is 5 minus 3n over 2 minus n. 5 minus 3n over 2 minus n. So to evaluate the limit of this, we can divide through by the highest power of n to get left off the limit sign. You can't leave off the limit sign. You have to write the limit as n approach infinity of 5 over n minus 3 over 2 over n minus 1. When n goes to infinity, we get 0 minus 3 over, plug in infinity, we get 0 minus 1. That's 3. So this one definitely converges because we get a finite value. As we can see, when we evaluate the limit as n approach infinity, we got a finite value. So this one converges. This one converges. Nice. Okay, that's done and dusted. Question 23. Given that Sn is equal to the sum from I equal 1 to n of 1 over I minus 1 over I plus 1, what's the limit of Sn? So let's go ahead and work out the limit of Sn. We're doing it on the whiteboard. We want to find the limit as n approach infinity of 1 over n or minus 1 over n plus 1. And instead of using I am using n. So don't worry, it's the same thing. I'm just using n. So we need to evaluate the limit of this. Actually, we need to find the limit of the summation of this. So we need to find the limit of the summation of this. All right. Now it doesn't look too tidy. Let's tidy it up. Put a summation sign. So we need to find the limit of the summation of this. So now what we get is the limit as n approach infinity of the summation of, work out the summation. When n is 1, we get 1. Plus when n is 2, it's 1 over 2. When n is 3, it's 1 over 3. And we'll continue to 1 over infinity, right? Just to say 1 over infinity. Minus, over this side, when you put in n is 1, you get 1 over 2. Plus, when you put in n is 2, you get 1 over 3. Plus, when you put in n is 4, n is 3, sorry, you get 1 over 4. And it keep on going and going till you reach 1 over infinity. So when we subtract, this half cancel this half. 1 over 3 cancel this 1 over 3. 1 over 4 cancel the 1 over 4. 1 over infinity cancel the 1 over infinity. So what we left back with is equal to the limit as n approach infinity of the sum from 1, to n of 1. Now, if this is what we're doing now, if we're summing from 1 to n of 1, the sum from 1 to n of 1 is just n. So evaluating the limit of, we're just adding 1, well, sorry, the summation sign gone. I don't know what I was talking about there. So just evaluating the limit of 1. The limit of 1 is just 1. So the answer is just 1. Like really and truly, that was so easy. Just 1. 1. That's it. All right. This says the coefficient of x to the 4 in the Taylor series expansion of f of x is cosine x about x equals 0. And you want the coefficient of x to the 4. Ooh. So let's go. We're having lots of fun here. So we have f of x is equal to cos x. So remember Taylor series, it's really Maclaurin series, and it's really Maclaurin. So remember that f of x is equal to f of 0 plus f prime of 0 times x plus f double prime of 0 times x squared plus f triple prime of 0 times x cubed plus f prime times 0 times x to the 4. So yes, there's a lot of derivatives to be found. Or there's a lot of derivatives for us to find. You know what I'm saying? Don't mind my grammar. If f of x is cos x, then that means f of 0 is the cosine of 0 and the cos of 0 is 1. Now f prime of x is going to be, when you differentiate cos, you get minus sine x. So when you plug in x as 0, you get f prime of 0 is minus the sine of 0, and minus the sine of 0 is 0. Now, f double prime of x is, when you differentiate sine, you get cos. So this becomes minus cos x. And so f double prime of 0 is going to be minus the cos of 0, which is negative 1. And then f prime of x is, when you differentiate minus cos, you get sine x. And so that implies that f triple prime of 0 is the sine of 0, which is 0. And then f prime of x is, when you differentiate sine, you get cos x. And so f prime of 0 is the cos of 0, and the cos of 0 is 1. So finally, in conclusion, we can write down that f of x is f of 0 is 1, so that's 1. F prime of 0 is 0, so this is 0, so that's plus 0, plus f prime prime of x squared, that's minus 1, times x squared. This part, f triple prime is 0, and then we have plus f prime 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 x to the 4, over 4. I forgot the 4 factorial, the 3 factorial over the 2 factorial and 1 factorial. That don't matter. We'll fix that. Then this f prime 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 prime, that is 1. So that is 1 over 4 factorial times x to the 4. So this is just a quarter x to the 4. I know this repeating, but I just couldn't remember that it was a quarter x to the 4. So the coefficient of x to the 4, we get 1 over 4 factorial x to the 4. 4 factorial is 24, so it's option B. I know it did repeat, but I just couldn't remember from which paper. Now, this says the equation x cubed minus x minus 3 equals 0 has a root on which interval? First thing, let's start when n is 1 to see. When n is 1, if we plug in 1, f of 1 would be equal to 1 minus 1 is 0 minus 3. That's minus 3. So f of 1 is minus 3. Let's check out f of 2. F of 2 would be 2 cubed. And my God, that is too difficult for me to cube. I know it's just the number 2, but nope. Doing that in the calculator. 2 cubed minus 2 minus 3. That's 3. This is positive 3. Now look at that. That is greater than 0. So the root lies on 1, 2. The root lies on 1, 2. So n have to be 1. All right. Since the root lies on 1, 2, the root has to be, n value has to be 1. So that was fairly simple. Soft. Question 26, which of the following is true? Let us see. The sum from one, this one is out. That's out. This one is out. You can't square the sum and get the same thing. Now, let's see this one. The sum from 1. All right, so this is it. All right, this one is true. Okay, nice. Because when you're adding 2 n times, it's 2 times n. So this is the same. Option C is fine. That's a unit 1 question, by the way. This is a repeat from unit 1. Imagine that. You take this off of one unit 1 paper. Come on, man. Unit 1 paper, that man. Nice. Question 27. Given that the coefficient of the term in b cubed is 40 in this expansion, then what is a? So the b cubed term, they tell us that is 40. So a plus b raised to the 5th, which we know is a to the 5th, plus, this is then 5a to the 4 times b plus 5a cubed b squared. It is the Pascal triangle I'm trying to remember. It's 1, 5, 10, 10. So this should be 10. All right. I don't want to use a binomial expansion. So guys, maybe you were looking for me to do it binomial expansion. I like to just, you know, do it different ways. Use the Pascal triangle now. So this is 10 times a squared b cubed plus 5 times ab to the 4 plus b to the 5th. Why did I do it this way? I just wanted to use Pascal triangle. The 1, 5, 10, 10, 5, 1. So after we did that now, they tell us that the coefficient of the b cubed, so this one of the b cubed, they tell us that that is 40. So that means they're telling us 10 a squared b cubed. They tell us that the coefficient of that is 40. So this is 40b cubed. So they're literally telling us that 10a squared is equal to 40. So a squared would be 4, and so a equal 2. So that's option A. All right, I just wanted to do it a different way instead of using the binomial expansion, just for a nice little challenge. It's always good to do things different ways. This one want the sum of the infinite geometric series is, I know this is a repeat, I think it's 135, I believe so, but I don't remember. We're just gonna check it out. 180 minus 60 plus 20 minus, so let's continue. This is 180 minus 60 plus 20 minus, and it continue. If you notice, right, this is 180, this is minus 60, so you divided it by 3, divide it by 3, divide it by 3, so it would be minus 20 over 3. Why is that important? That's important because this is really, I'm going to separate it as two different geometric progression. This is the 180 plus the 20. Let's consider that part and consider the part where you have minus 60 minus 20 over 3. If you do it like that, then you can call this geometric progression 1, and you can call this geometric progression 2. The sum to infinity of the geometric progression 1 is going to be A, which is 180 over 1 minus R. 1 minus R, the common ratio is 20 over 180 over here. So the sum to infinity is going to be A, which is minus 60 over 1 minus R. R is 20 over 3 divided by 60. Ooh. So this one works out to be, I know 20 over 180, that's 1 over 9. 1 minus 1 over 9 is 8 over 9. This is 180 over 8 over 9. And over this part, the sum to infinity is 20 over 3 divided by 60 is the same as multiplied by 1 over 60. 20 into itself 1, 20 into 60, 3. This is the same 1 over 9. So this is just minus 60 divided by 8 over 9. So now why did I do that? Now when you add these two, when you add the two of them, that's going to give you the infinite sum. So let me call it S total. The infinite sum is when we add these two. So let's go ahead and add these two in our calculator, because you don't know, we can't do that mentally. Well, if you can, that's great. So we have 180 divided by 8 over 9 plus, right here, so now is 180, not 180, minus 60 divided by 8 over 9. Punch that in our calculator, that is 135. I knew it was 135, you know. I just couldn't remember that it was 135 because it's a repeat. I just couldn't remember. That's option C. Question 29 says a suitable Newton iteration for this is, so let's look at it. We have e to the 2x plus 4x minus 5. So go around here. E to the 2x. The question said e to the 2x plus 4x minus 5 equal to 0. So this is what you have, and you want to find an iteration, right? Well, they must give you the first iteration. They didn't give us any, so in this case, we're going to call our first iteration xn. So using the Newton-Raphson method, remember that xn plus 1 is equal to xn minus f of xn over f prime of xn. You have to remember that formula. So now this is going to be xn minus f of xn is going to be e to the 2xn plus 4xn minus 5 over f prime of xn is when you differentiate this up here to get 2e to the 2xn plus 4xn. Now join this as one fraction. It's going to become, as one fraction, it is xn times 2e to the 2xn plus 4xn Well, I don't have space to add it right here, so let me just do it below. All right, just making the space, making the space. So this now, I think we have enough space now. So finally, xn plus 1 is equal to 2exn plus 4xn. All of this is multiplied by xn minus, in bracket, e to the 2xn plus 4xn minus 5 over 2e to the 2xn plus 4xn. Simplifying the numerator, 2e to the xn times xn is 2. This is now 2xn e to the xn. All right, then this part is now 4xn squared. So that's minus 4xn squared. Then this is now minus 2exn minus e to the 2xn minus 4xn plus 5 over the 2 times e to the 2xn plus 4xn. Whoa, that's a lot to write out. So let's see which one that is. Now notice they did some factorizing. So they factored out e to the 2xn from the numerator. E to the 2xn can be factored out from this term and this term. So if you factor it out from those two terms that I did right there, right? If you factor out e to the 2xn, because that's what they did. They factored out e to the xn. Then we're left back with, from this side, it is 2xn, factored out e to the xn, minus, factor out e to the xn from this, we're left back with minus e to the xn from this. This is not what I'm getting. Let me look back at this. All right, they're factoring out e to the 2xn, but I don't have e to the 2xn. I have e to the xn here. So what went wrong? When I cross multiply, oh, this should have been e to the 2xn here. This is e to the 2xn here. When I cross multiply it up, 2. That's e to the 2xn. All right, so now I get it now. E to the 2xn factored out. That's just 2xn minus e to the 2xn. This is minus 1. So this is 2xn minus 1. I'm looking for one of them with a bracket with 2xn minus 1. 2xn minus 1. Option, it can either be option B, it can either be this, or it can either be this. Now, which one do we have? Is it the plus 5 or the minus 5? Let's check our answer. We have a plus 5 at the end. So since we have a plus 5 at the end, it is option B. Okay, nice. This one says the coefficient of x to the 11. So to find the coefficient of x to the 11, this is one now that we're going to use binomial expansion. So since we need 11, remember, we're going to multiply it by 2. So it's 2 times, in bracket, we need x to the 11 term, so we need this one to be a to the first power 1 x to the 11. So this is 11, choose 12. So that's what we need to work out. 2 times 12, choose 11, a to the 1 times x to the 11. Then this part is the coefficient of x to the 11. So we're going to take out our calculator and work that out. So take out our calculator and put 2 times in bracket. This is now shift, and let's go ahead and work that out. This is 12, choose 11. Close up that. To work it out, and so what we get is 24, and so that's 24 times 8. That's 24a. Nice. So that's what we get. That's option B. Question 31, it gives us this matrix here. If M is this matrix, the first row of the cofactor matrix of M is, so we need to find the cofactor matrix of M for the first row, all right, for the first row. So all we need to consider is, remember what is M? M is, I'm just looking at M right here, 133 minus 241. Let me write out the 133 first, 133. Then this is minus 241, minus 241, and then that is 0, 5, 6. 0, 5, 6. So if this is M right here, and we need the cofactor of M, so the cofactor of M is going to be, for the first row, remember it is plus times, you cross out the row and the column with 1 in it, that's 4, 1, 5, 6, minus the determinant of, cross out the row and the column with 3, that's minus 2, 1, 0, 6, then plus the determinant of minus 2, 4, 0, 5. We don't need the rest down here, so we can just put star, 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 and star. Working out the cofactor, we're going to get 4 times 6 is 24. 24 minus 5 is 19. Now here, so you're going to get minus 2 times 6 is minus 12. Minus 12 is positive 12. Then here, so is minus 10 minus 0, so this is just minus 10. So it's 19, 12 minus 10. That's the cofactor. 19, 12 minus 10. See it here, option C. Nice. This question says, in how many ways can the letters P, Q, R, S, T, U, be so that T and U are always together? If T and U are always together, think of them as 1. So that's like 1 letter, 1, 2, 3, 4, 5 letters. That's 5 factorial ways. But then if they're always together, it's either T on this side and U the earsaw, or U the earsaw and then T the earsaw. So that's times 2. 5 factorial times 2 is option D. All right, nice. Question 33, as you can clearly see, all options are incorrect. The correct answer is 3 over 10. So yes, guys, sometimes keep the questions where the answers are not correct. And what they do is they skip out that question. So this one, there's an error in the question because they want, what is the probability that the product of these two numbers is prime? It says the product. Now, if you take out this question, this part of it with the product, the question would be fine. But for the product of the two numbers to be fine, look at this. If you draw 2 cards randomly from a pack of 5, you can either draw 1 and 2, you can draw 1 and 3, you can draw 1 and 4, or you can draw 1 and 5. Then now you can draw 2 and 3, or you can draw 2 and 4, or you can draw 2 and 5. Or you can draw 3 and 4 and 3 and 5, or you can draw 4 and 5. Those are 10 options. Now, what are the chances for it to be prime? The product of the two numbers to be prime. In order for the product of the two numbers to be prime, you can either draw 1 and 2, 1 and 3, or 1 and 5. Those will give us the prime number. We multiply 1 times 2, 1 times 3, 1 times 5. That gives you prime. So that right there is 1, 2, 3. There are 3 possibilities out of the total possibility being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 3 out of 10. 3 out of 10 is not there. So this question have an error in it. All right. So that's that. This question says, given that y equals 0, at x equals 0, find the general solution of this differential equation. So as we can see right here, we have y double prime plus 6y prime plus 9y is equal to 0. That's what we have to solve. Now this right here, so let's write down our characteristics equation that we're going to solve. This is u squared plus 6u plus 9 equal to 0. We can factorize it. That's u U, signs are the same, both of them positive, 3 and 3 plus and plus. So U equal minus 3 repeated. If U is equal to minus 3 repeated, then that means Y is equal to E to the minus 3x in bracket A plus BX. This is your general solution. But then what did they tell us? They told us when x equals 0, y equals 0. So that means that when x is 0, y is 0. That can find one of the constant then. When x equals 0, y equals 0. So that means 0 is equal to e to the minus 0, because 3 times 0 is 0, times a plus b times 0. Now e to the minus 0 is 1, because e to the 0 is 1. E to any power, e to the 0 power is 1. So that is a. E to the 0 is 1. 1 times a is a. So that means that a equals 0. So that means that therefore y is equal to e to the minus 3x multiplied by 0 plus bx. So the final answer is y is bx e to the minus 3x. So that's bx times e to the minus 3x. Bx times e to the minus 3x, that's option B. Nice. Question 35, a suitable integrating factor for the differential equation. First thing, it's dy by dx plus k times y equal to 1 over x. So the integrating factor I like to call it I, is e to the integral of the 2 over x dx. When you integrate 2 over x, you get integral of 1 over x is ln x. So this is 2 ln x. And when you integrate, when you have e to the 2 ln x, you can bring up the power to write e to the ln x squared. Then e cancels the ln. And since e cancels ln, this is just x squared. That's the integrating factor, x squared. Nice. Now, the next part says 2 coins and a die with faces numbered 1 to 6 are thrown together once. Assuming that the die and the coins are fair, the probability of obtaining 2 heads and a number less than 4. So if we get 2 heads and a number less than 4, there's a half a chance to get a head. Well, let's look at it right here. All right. So I just want to show you all the possibility where kind of makes sense. If you were to look at all the possibility, you can get a head, you can get a head and 1. You can get a head and 2, a head and 3, a head and 4, a head and 5, a head and 6. All right, I just want us to see all the possibilities. So it kind of makes sense. Now, all of these, you can get it if the second one was like a tail, a head and a tail and a 1, a head and a tail and a 2, a head and a tail and a 3, a head and a tail and a 4, a head and a tail and a 5, a head and a tail and a 6. Likewise, it could have been a tail first. So all of them here, where you get, you multiply it by 2. And then finally, you can get tail and 1, tail and 2, tail and 3, tail and 4, tail and 5, tail and 6. Those are 24 possibilities. Now, what are the chances that you're going to get 2 heads and a number less than 4? Less than 4 is 1, 2, or 3. So that's 3. Find the probability of obtaining 2 heads. That's what it said. They get 2 heads and a number less than 3. So this is when you get 2 heads and a number less than 3. All right. So that is 3 out of 24. But let's see. Why do we not have these? So let's just go back here. So we need to find the probability of getting 2 heads and a number less than 3. I'm just going to write n less than 3, all right? And so that's what we want, getting 2 heads and a number less than 3. So if we get 2 heads, that means that the first one have to be a head and a half, times the second one have to be a head is a half, times a number less than 3. So if we get a number less than 3, there are 6 numbers and there are 3 numbers less than, was it 3 or 4? Less than 4. There are 3 numbers less than 4. Right here, there are 3 numbers less than 4. So as we can see, this is 1 times 1 times 3 is 3. 2 times 2 is 4. 4 times 6 is 24. That's 3 out of 24. So as we can clearly see right here, this is not giving us the 3 out of 24. This is really off. This is 3 out of 24. Find the probability of getting 2 heads and a number less than 4. Numbers less than 4 are 3, 1, and 2. We get 2 heads to them here. 1, 2, 3 options out of 24. 3 options out of 24. All right. And as you can see, we'll do it by the calculations here. Probability of getting 2 head mean to get 8 on the first coin, 1.5 times 8 on the second coin, 1/2, less than 4. That's 3 out of 6. That's 3 out of 24. Not there, so I don't know what they're doing, but that's not there. All right. So we'll leave that one because that should have been 3 out of 24. I will examine that question and keep us all posted about it. So number 36 and number 33, you can see these 2 probability questions, something a bit jittery or off. Okay, now this one, it says find the cofactor of the element in 3. So this is plus minus plus minus. So it's minus the determinant of cross the row and the column with the 3. That's 1, 4, 0, 5. That's option B. Nice. Question 38, find the general solution of the differential equation dy by dx equal y over x. dy by dx equal y over x. So dy by dx is y over x. We can cross multiply to get x dy is equal to y dx. Now what we can then do is flip it to say 1 over x, or let me not do that right away. What we can do is flip it from right here to say dx over dy is equal to x over y. Now why did I do that? Because now I can divide through by x to end up say 1 over x dx is equal to 1 over y dy. Now once I get to this part right here, I integrate both sides. Then when I integrate both sides, the integral of 1 over x dx is going to be the integral of 1 over y dy. The integral of 1 over x is ln x, and that's equal to ln y plus some constant k. Or some people like to write it as ln y equal ln x plus some constant. Let's call k ln a. So therefore, ln y is equal to ln a times x. So y is equal to a times x. That's it. Y is a times x. Nice. A times x, k times x, doesn't matter which constant you use. Question 39. Which of the following equations or statements are true? All right. So we have these 3 equations right here. 2x plus y minus z equal 4. Let's test it out. 2x plus y minus z is equal to 4. Going back around here, we have x plus y plus z equal 1. X plus y plus z equal 1. And then coming back around here, we have 3x minus 2y minus z equal 2. 3x minus 2y minus 2z equal 3x minus 2y minus z equal 2. And then they want us now to just go ahead and solve that right there. So we're just going to put it in augmented matrix form. This is now 2, 1, minus 1, 4. This is 1, 1, 1, augment 1. This is 3, minus 2, minus 2, 2. So if this is what we want, now what we can do is row reduce. So to row reduce, I'm going to interchange row 2 and row 1. I'm going to interchange row 2 and row 1 and put row 1 here. So as 1, 1, 1, 1. This has 2, 1, minus 1, 4. And this has 3, minus 2, minus 2, 2. Why did I do that? So I can apply changes now to row 2. And so now row 2 is going to become 2 row 1 minus row 2. So 2 times 2 minus 2, that's going to end up giving me 0. 2 minus 1 is 1. 2 minus minus 1 is 3. 2 minus 4 is minus 2. Now row 3 is going to become 3 row 1 minus row 3. Now 3 minus 3 is 0. 3 minus minus 2 is 5. 3 minus minus 2 is 5. And then 3 minus 2 is 1. So now I need to augment one more time. 1, 1, 1, 1, 0, 1, 3, minus 2. Now row 3, I'm going to let it become 5 row 2 minus row 3. Now 0 minus 0 is 0. 5 minus 5 is 0. 5 times 3 is 15. 15 minus 5 is 10. And then 5 times minus 2 is minus 10. Minus 10 minus 1 is minus 11. So what it's giving me is a unique solution. So from this, I see that the equations are inconsistent. One is not true. The planes are not parallel. They're not parallel, that's true. So 2 is true. The equations have a unique solution. So it's 2 and 3. 2 and 3 is option C. Nice. Question 40, it says, from the letters A, B, C, D, E, the number of 3-letter words that can be made if no letter is repeated. So 3-letter words, how many letters are there? 5, so we need to group them up in 3. So group them up in 3 from a total of 5 letters. And so it's 5 choose 3. You put 5 choose 3 in a calculator. Let's see. 5 choose 3. We get 10. So that's option B. Option B is 10. All right, that's option B. Now, question 41 says the number of possible values of x which satisfies the equation is. So as we can see right here, look at this. The number of possible values for x. Now, as you can see, this is a multiple of this, right? 2x, 4x, 6x. If you multiply 2x times 2, you get this second one. So if I multiply this equation by 2, we get the second one. If I multiply the first equation by 3, I get the third equation. So there's no solution right here because this is a minus 11, it should have been minus 10. There's no solution. This system is said to be inconsistent. So none, this is inconsistent. This system is said to be inconsistent. Now, question number 42. AB equal J, BC equal K, CD equal 11, ABC equal P, BCD equal Q. What's the product of ABCD? Now, ABCD can be looked at as A times B times C times D. BCD is Q, so one possible answer is A times Q, that's not there. ABCD can also be written as AB times BD. AB is J, BD is BD, AB times CD, sorry, and CD is K, so JK is a possible answer which is not there. Or you can say that ABCD is equal to ABC multiplied by D. ABC is P times D. So PD is option D. All right? Nice. So those are the possibilities. Question 43. Chad, Matthew, Josh, Paul, Tiffany are traveling in a 5-seater car with 3 persons in the back, 2 persons in the front. Each person occupies 1 seat. The number of different ways they can sit in the car if Tiffany sits in the back and Josh drives. So I'm just going to draw a little mock imitation of the car. All right, so let's say these are the front seat. And the table says Joshua drives. So Josh is right here. This is Josh driving. And it says that who must sit at the back? Tiffany must sit at the back. So this is Tiffany's seat, all right? Tiffany must sit at the back. So if Tiffany must sit at the back, now we're left back with any of the 3 persons can group here. So what do we notice, right? Look at this. So 1, 2, 3, 4, these are the 5 persons. Josh is driving and Tiffany is sitting at the back, all right? So we're left back to choose now any person sit here. So Chad can sit here, Chad can sit here, Matthew can sit here, Paul can sit here, or Paul can sit here, Josh can sit here. It don't matter how we arrange up these 3, all right? But we just know that Josh drives and Tiffany must sit at the back. So now let's look at the different ways now. Now we're going to work out the different ways for which Tiffany sits at the back and Josh is driving. So this is known as, we're pretty much working out permutation and combination with restrictions. These are the restrictions that we have. So we need to find the total ways first. The total ways would be 5 factorial. And 5 factorial would be 120. That's if there was no restrictions. Now with the restrictions, now with Tiffany sitting here and Josh sitting here, now that means that the other ways would be any of the 3 can sit here, any of the 2 can sit here, 1 can sit here. So the restrictions is equal to 1 times 2 times 3, which is 6. 120 minus 6 is 114. So there are 114 ways that, you know, they can sit with Tiffany being in the back and Josh driving. Question 44, find the general solution of this differential equation. First thing we need to do is solve the characteristic equation u squared minus 3u equals 0. We get u equals 0 and u equals 3. And so y is equal to a times e to the 0x plus b times e to the 3x. E to the 0 is 1, so that's y equal to a plus b e to the 3x. Which one is that? The a and b can be c1 and c2, so that is pretty much b times e to the 3x, or c1 e to the 3x plus c2. That's option C. Number 45. Find the particular solution when they give you that dy by dx is 2x cos square y. We can divide through by cos square and cross multiply to write 1. Bring down this is 1 over cos square y dy is equal to 2x dx. 1 over cos square is sec square. So this is sec square dy equal 2x dx. You can then integrate both sides. When you integrate tan sec square, you get tan y. Then when you integrate 2x, you get x squared plus k. But then look at that. It told us that when y is pi by 4, x is a half. The tan of pi by 4 is 1. When x is a half square is a quarter plus k. So k equal 3 over 4. That clearly is option A. So that takes care of the 2020 paper 1. I will keep us posted regarding to the 2 MCQ questions that we couldn't find a solution for. With that being said, keep on practicing, stay safe, stay blessed, stay tuned for more. Have a blessed day.